Hello there, ladies and gentlemen. Welcome to a new module. We are going to be talking about solving a system of equations, specifically using graphing for this first part. Now, that sounds like something new to you guys, but we're actually going to start with something familiar that we've done before, basically just graphing a line in general. If you remember how to graph a line, everything that we talk about from here on out really just boils down to that fact. So if you remember how to graph a line, all of this you're going to see is pretty much just kind of like repeating that skill over and over again. Okay. So just a little review on how to graph a line. So here we have a line in y equals mx plus b, and what I need to identify is what my slope and my y-intercept is. Now, if you remember, the m would be our slope, so in this case that'll be 2, and the b will be -3, and that's our y-intercept. So when I go to graph, I start by graphing the y-intercept. In this case, -3. So I'm going to go down 1, 2, 3 is where -3 is, right there, and I'm going to put a point. Then I go ahead and use the slope, in this case 2. I can think of it as 2 over 1 if that helps me out. And that's how I'm going to go ahead and graph the other points of my line. So I'm going to go up 2 over 1, put a point. Up 2 over 1, put a point. Remember, the top number, the numerator, tells us up and down. The denominator tells us to go to the right. I'll go up 2 to the right 1. If I wanted to add points the other direction, let's say I want to add points to the left, which as we're going to see later, sometimes is going to help us when we go to do this. I can go to the left, but if I go to the left, I just do the opposite of the top number. So instead of going up 2, I'm going to go down 2 and to the left 1. And all the equations we're going to be graphing are going to be lines. So because they are lines, that means that we know that they should all be in a line with each other. So if we end up getting something that's curving or making a W, if you remember back when we did this in class, we know that we didn't do it right, okay? So now what I'm going to go ahead and do is draw my line through all these points. And again, I apologize for my line not being super straight. Writing with a mouse is a little bit difficult, but that's basically what we're going to be looking for. Is we want these points to be shown to us so we can see where they are, and then we draw our line to give an idea of what that looks like, and that is us graphing a linear equation. Now, if you remember from class, we talked about graphing one linear equation. We talked about the fact that they had an infinite number of solutions that worked for them. Anything we could plug in for x and get a y value out was a solution. So for example, I put in 0, I would get out -3 for y, and that's all my line. That's a solution to this line. If I put in 2, I would get out 4 minus 3 is 1. So I go over here, let's see, 2, 1, there's a point on my line. That would be a solution to this. What we're going to do, though, today is we're going to kind of add on to this a little bit by looking at what if I graph two lines? What if I have two different lines and I look to see where those two lines intersect or where they touch each other, where do they overlap? And that's going to be what we call the solution to a system of linear equations where we have more than one line that we're looking for an answer to or a solution to, okay? A little bit of vocabulary and things for us to go over here. So just a little bit of vocabulary for us to go over. So when we're graphing linear equations, in terms of a system, we're looking at two or more linear equations that are in the same coordinate plane, meaning we're going to be taking these two lines, we're going to graph them, and mainly what we're going to be looking for is what's called a solution to that system. And the solution is when we find, this should just be a point, okay, or an answer or some place that will satisfy each equation in the system. And mainly what we're going to be looking for is where these two lines intersect. Where do they touch each other? Wherever they intersect, where they touch each other, that's going to be where we have that point that satisfies both parts of our equation and satisfies our entire system. Okay, so we're going to kind of scroll down here and kind of look at a couple examples of what can happen when we go to graph some of these. Okay, so here's kind of one example. So I have y equals -3x plus 1, and I have y equals -2x minus 1. In terms of what you're going to do, you are going to do this exactly how you would graph a line normally. The graphing is not going to change at all. Meaning, I'm basically just going to graph this top line, and then I'm going to graph this second line, and that's all I'm going to do. So for the first one, I'll go up to 1, put a point. I then have a slope of -3, so I'll go, let me move this over here. I'll go down 3 over 1 and put a point, and I'll do that a couple times. Down 3 over 1, put a point. Down 3 over 1, put a point. And then that's going to be my line for the first one. Okay. Now let me go ahead. I'll change my color to blue for the other one, but we'll say this is the blue line here. So I'll go ahead and graph this one. So we're going to start at -1. I'll put a point there. And then I'll go ahead and I'll graph this one like normal as well. So I'll go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And I'll go ahead and I'll draw that line as well. And basically all I'm going to do is look for where did I draw a point for both the blue line and the black line in this instance, okay? Or where did I draw a point for both of them? That's going to be my answer. That's going to be the solution where they're intersecting. I can see that's going to be right here. Right there, I drew a point for both of them. I drew a blue point and a black point there. So let's see, that would be at 1, 2. And then if I go down, 1, 2, 3, 4, 5. So it looks like 2, -5. Okay, they meet at 1 point, so there is one solution. That is one thing that can happen. And in this case, it's going to be at the point 2, -5. Now, if you ask yourself, okay, Mr. Guy, I went ahead, I graphed, I found the point or whatever, is there a way for me to check if the answer that I got makes sense and if it's the correct answer? Well, to check it, all you have to do is check it just like we would when we checked solutions to our other equations. I can plug this in for x and y and make sure that it makes both my equations true. So like for example, in this top equation, if I plug in 2, I'm going to have -3 times 2 plus 1, which will equal -5. So that does satisfy that first equation for me, so I know my answer is correct. I then can also check in the second equation, -2 times 2 minus 1. And if I do that, I'm going to see that's also going to equal -5. And I can see once again that that also makes this equation true. So this point satisfies both of them. It is the solution to our system. That's one thing that can happen. Basically, I graph them. I see they touch. I go, okay, cool. They touch. There's my answer. That's what I'm looking for. Okay. That's what's going to happen a really large majority of the time. However, there are some other weird things that can happen sometimes. For example, when I go to graph these two, this time I'll pick, we'll do green and we'll do blue for this one. Okay. So I'll go ahead and graph these. So let's go ahead and let's start with the green one. So let's see, we're going to start at -2 and then our slope is 1/2. So we're going to go up 1 over 2, up 1 over 2, up 1 over 2, and I can do that a couple times. If I want to go backwards, remember just do the opposite, so go down 1, left 2, and then I'll go ahead and draw my line. Now I'll go ahead and do it for the blue one here, so we're going to go to -1, and we'll do the same thing, up 1 over 2, up 1 over 2, up 1 over 2, and I do that over and over again, and oh, what are you guys starting to notice here? These two lines, when I draw them, are never going to touch each other. In fact, if you remember back to geometry from last year, what do you notice about these two lines? They both have the same slope, meaning they are parallel. And parallel lines are never going to intersect. They're going to go on forever, and they're never, ever, ever going to touch each other. In fact, I always say it's the worst love story ever told. They're going on the same path forever, but they'll never meet. It's really sad. Okay? Whenever this happens, and especially you'll notice it even before you go to graph, because you'll see that you have the same slope but different y-intercepts. If you ever notice that, that means that you have parallel lines, as we just said. Okay? And the issue with parallel lines is that they are never going to intersect. So they don't intersect. It's a really beautiful don't. They don't intersect. Because they don't intersect, guess what solutions you have? You have no solutions. Nothing is ever going to work. You can never come up with a number that's going to work for both of these equations. It's not going to happen. So those are the first two things that can happen. You can either have where they touch and you get your answer. Those are intersecting lines. Sorry, I should have filled that in when I did that. And that's going to happen most of the time of the ones that we're going to look at. However, every once in a while, you're going to see ones that are parallel. And the parallel lines means that they're going to have no solutions because they're never going to touch each other. However, there's a third thing that can happen, and this one happens every once in a while, where we're going to see our two lines have even something even weirder going on with them, okay? Again, we'll go ahead and we'll do blue and green for this one as well. So I'll go ahead and graph each of these. Let's start with the blue line. Okay, I have a slope, I have a y-intercept at 2. My slope is 3, so we're going to go up 3 over 1, up 3 over 1. If I want to go backwards, I just have to do the opposite. And then I'll go ahead and draw my line. It's a little off, but we'll see what happens in a second. And then we'll go ahead and do the green one. Now, if you notice by the green one, this one is not in y equals mx plus b. In order for me to graph it, I want it to be in y equals mx plus b. That's going to make it a lot easier for me. So I need to get the y by itself. So to do that, I'm going to go ahead, I'm going to add 3x to both sides. Okay? So adding 3x to both sides, what that's going to do is that's going to move this over to the right and get it out of here and make the y be by itself. So I'm in y equals mx plus b. So I'm going to have y equals 3x plus 2. And then we'll go ahead and we'll graph. I don't know about you, but I'm already starting to have a little bit of deja vu. I'm at 2. I go up and over, up and over. I can go backwards. Yeah, this is looking a little familiar. Kind of looks like these lines are right on top of each other. In fact, if I look at their equations, y equals 3x plus 2, and the blue one was y equals 3x plus 2. They're the same. Interesting. Okay? These are the same lines. Okay, the same lines, or as we call them, they're overlapping lines. When we go to graph them, they're exactly the same. Okay? Everywhere is going to work. So that means that there are infinite solutions. There are infinite different things that I can come up with that would work in this equation for this system of equations. I do want to say, make sure you're being careful. Having infinite solutions does not mean everything's a solution, right? The point 2, -1 is not a solution. It doesn't work. However, there are infinite things I can come up with that do work. 0, 2 works. 2, 5 works. Or 1, 5 works. 2, 8 works. So on and so forth. There's infinite things I can come up with because they are the same line. That is how we're going to be doing graphing of these equations. Okay, basically there's 3 things you're going to look out for. The main thing, ladies and gentlemen, that you need to remember to try to keep you not to stress out and just to look at what we're looking at here. If you know how to graph a line, this is just that. You're just going to do it twice. Okay, the main thing you have to do is after you graph those 2 lines is basically just say, do they touch each other once? Then that's my answer. Do they touch each other not at all? Then I have no answers. Are they always touching each other? I have infinite solutions. That's all you need to do. So if you remember how to graph these lines that we're looking at, that's the main goal. Graph the 2 lines, and then, okay, let me look and see and get my answer from that. Okay? Thank you for watching, and I hope you guys are staying safe and staying healthy.